Fluid mechanics, a short but annoying topic. So, first thing to have in mind, a projectile's flight path. So, projectile is the thing that you throw into the air. It's mostly determined by initial velocity, the velocity at the start, the first few seconds, and the angle of projection. So, an example, baseball bat. We bat the ball, it moves this distance, okay? This distance has a name, we'll look at it later. But what's the angle of projection? This would be the angle of projection. You project it from this straight line 45 degrees in this example, okay? Now, motion of an object projected into the air or dropped, okay? This is the projectile flight path. Next, the forces acting on a projectile, apart from the force from the person that's making the projectile move, are gravity and air resistance. Now, air resistance, when negligible, so when it's basically not noticeable, when the effects are not very high, only gravity will act, because gravity is always significant. And this means that horizontal velocity will stay constant and vertical velocity will actually change. Now, the full distance that the projectile is going to travel is called the projectile range, and is the full horizontal distance that is going to travel from the starting point to the ending point. When we're looking at things from the ground, so the height being 0, in that case, a 45-degree angle projection will have the highest projectile range on flat grounds. So flat grounds, that's 0 meters up in the air. 45 degrees will be optimal if you want your projectile to have the most flight path or the most projectile range. Also have in mind that the angle of projection is also important for the maximum height of the flight and the accuracy of such. Now, projectile flight path is mostly determined by these two, but then it's followed by the mass and the height of release, the height at which the projectile is released. Those are other factors determining projectile flight path. More height of release increases the projectile range, so the horizontal distance the projectile moves from the starting to the ending point. So you compare 2 meters to 4 meters. If we move the projectile with the exact same initial velocity, force, the projectile has the same mass, we'll see that it's going to have a higher projectile range at the higher height of release, which is 4 meters. Now, if the target landing point is higher, such as, well, if this would be ground level, we first need to look at ground level first. If the target landing point is higher, like this top bins, you'll need a steeper angle of projection in order to reach there, okay? So it's going to travel higher up. Now, on the other hand, if the target landing point is lower, you need a negative angle of projection, okay? This is phrase right here. So kicking down requires a negative angle of projection. If you were to hit something backwards, you would need a very high angle of projection. Okay, we're talking 270 degrees, something like that. Anything above 90, really, because 90 would just go straight up. And if you wanted a negative movement, so for it to go down and you want it to go backwards, what's going to be a negative high angle of projection? In the last slide, so we're looking at air resistance. As we've seen before, this force impacts projectile range and pathway. And this is because it's going to cause faster deceleration or negative acceleration. For faster moving objects, this is going to be increased. And for slower moving objects, because the magnitude of air resistance is small in comparison with the force of gravity, well, it's going to cause less deceleration. So slow-moving objects are less impacted by air resistance. Therefore, they will follow a more typical projectile flight path. And um, there's another case where the force of gravity is way higher than the magnitude of air resistance, and that's when the projectile, the object moved, is heavy. Because it's heavy, there's higher weight, higher gravity acting on it. So slow-moving objects and heavy projectiles will follow a typical projectile flight path. And how do you know if it's typical? Well, it's going to be more symmetrical, looking like this. You know, if you divide it into two, it's pretty symmetrical. Now, light objects or faster moving objects, they're going to have an atypical flight path, which is mostly going to be asymmetrical. Okay, so if you've ever played with a shuttlecock before, you know, you've played badminton, you'll know that this shuttlecock moves pretty randomly. It's very asymmetrical.